one thing you should have on your desk is a pencil and your science binder. As Ms. Springer stated, we're going to learn about simple machines. When you guys leave here, I want you to be able to classify the 6 simple machines, okay? Have you heard of simple machines before? No. You don't learn that? No. That's okay because we're going to learn it today. There are 6 simple machines. A pulley, a lever, a wedge, a wheel and axle, and an inclined plane. I'm going to pass out the worksheet you're going to take notes on, okay? Now on this worksheet, I just want you to jot down somewhere the 6 simple machines. Just list them anywhere on the paper.
You put it in your box? Or
no. Make sure you write your name and period at the top. You just write these down. It can be at the bottom or anywhere on your paper. I just need for you to be able to go back to look at them. You can just write it down here if you want to. I need you to When you're done writing, look up so I can know you're finished. Okay, so we're going to play a quick game of Name That Simple Machine. I'm going to show you a picture, and just by looking at the picture and knowing what these 6 are, I want you to raise your hand, and I will call on you, and you tell me which one you think it is, okay? Does everyone understand? Okay? The first picture. Ronnie?
Wheel and axle.
Wheel and axle. That's a great guess. Does everyone agree with her?
Yes.
Okay. The second picture. Brandon. I'm sorry, not Brandon. L.U.
Screw.
A screw. Does everyone agree with them?
Yes.
That's right. What about this one? Kiara? A pulley. That's correct. What about this one, Orion?
Inclined plane.
Inclined plane. You guys sure you haven't learned this before?
No, I don't remember. I think we did.
What about this one? Tania?
A wedge.
A wedge. I can see how you get that. Anyone else have another guess? That's a great guess. Mark?
A seesaw?
That's not a simple machine.
Lever.
A lever. That is correct.
Yes.
What about this one? A wedge. I think you guys have learned this before because you got all of them right. Okay. Now this is where your note-taking worksheet will come in hand. It's going to go straight in order. So I want you guys to pay close attention. Also, there are small video clips inside that answers to some of these. Okay? The first part tells you the name and define it. The second part says what it does. This is asking you, what is this machine used for? The last one says example. You notice it's blank. I want at least 2 examples for each machine. Okay? Yeah, make it bigger. Simple machines are made to make work easier for you. Could you carry that cabinet up a flight of stairs by yourself? No, it's heavy. You need a machine to move it, right?
Yeah.
So that's what simple machines are here for. It's going to make it easier for you to carry that. Okay? They change the direction of something, increase speed, or increase the force. Increase speed. Have you guys ever rode on a bicycle going down a hill?
Yes.
That's increasing the speed where you're walking really fast to go down a hill, right?
Yeah.
Okay.
It's too hot to keep grabbing. You never finish the fort if you keep complaining. It's okay. We can move the fort up to the porch. These are too heavy. Yeah, they are. I know. What's in here? We can move it up the stairs. Wow, that doesn't look any easier. I've got it. I can move all the rest of the rocks with this all by myself.
Kelsey found the right machine for this work.
That does not look like a machine.
A machine is anything that helps us do work.
But I thought they were just playing.
Work is done when something is moved. So the children were working when they moved the rocks. You need force to make something move. A force is a push or a pull. The kids use force to lift the rocks, to push the box up the ramp, and pull the wheelbarrow.
But when I think of machines, I think of washing machines, cars, and mowers.
Those are more complicated machines. They're called compound machines, and they're made up of simple machines.
Okay, how many of you guys could have just moved that box of rocks by yourself? You could have moved the box of rocks. It looks pretty heavy to me. Oh, 2 other people? Why would not you just use a simple machine to make that easier?
Probably you don't have the materials.
If you don't have the materials, that's true. However, you notice they got the wheelbarrow and it just moved right on up. They were pushing it up the incline plane. Didn't that look hard still?
Yeah. Sort of.
Sort of. So we're going to learn about the different machines that can help you make this work easier. Okay, our first simple machine is the pulley. It says a pulley is a simple machine that has grooved wheels and a rope to raise, lower, or move a load. It helps change the direction of the force. Here's an example of a pulley. You see the rope and you see the wheels, right? You see how that moves because I'm using this pulley? Have any of you ever went to go try to lift the flag? Pull the flag up using the rope?
Yes.
Can you just pull it and the flag just automatically goes up?
No.
No, you have rope and you have the pulley. and higher, right? An example would be a flagpole. And here you can see the pulley. Another example would be a clothesline. Now I know you guys do not have clotheslines at your house. Most of you have wash machines. But if you do have a clothesline, you know that a rope goes through there. And you hang your clothes on there, and as you're turning, this is going and the line is going, right? That's another example of a pulley.
The direction of movement is changed. It doesn't make you any stronger. In a movable pulley, the pulley moves on.
That would talk about the two different kinds of pulleys, which is under here. You guys don't have to know that, so we're not going to go over. You can skip the 2 bulleted points. Okay? The next one is a lever. If I'm going too fast, just please raise your hand and let me know, okay? A lever is a stiff bar that rests on a support called a fulcrum. How many of you have ever got on a seesaw with your friend? Did you notice that there's something in the middle that doesn't move even though you and your friend are moving?
Yes.
That's the fulcrum. This right here is not moving, but it's the fulcrum. This is the lever. It's a stiff bar. If you sit down and your friend weighs more than you, are you going up or down?
Up.
Up. So it's lifting you, right? A pulley, not pulley, a lever lifts and moves loads. An example would be a seesaw. Some of you may call it teeter-totter. Another example they have is a bed. See how the elephant weighs more? Therefore, they're being lifted. An example would be a bat as well. I know you guys are thinking, but that doesn't go up or down. No. But if you're holding onto the bat and you swing, your force is being applied. You're holding. You swing. Is the tip of that bat moving? Applying a force to something when you hit the ball? Yes.
And what's the first one?
So a bat can be another example. Over here.
So you want to do it?
You're on the right side. The one that says a pulley and a lever. Yes.
Where does the world is?
It's. Okay, hold on one second. Everyone should be on the side that says pulley.
Now we got it.
No.
You guys should have been completely lost when I was going over this then.
Yeah.
Because this goes in order. Okay, I'll go over it with you, the pulley again.
Thank you.
I'm going to go to the next one. So start where it says lever.
A lever is a board or bar that rests on an unmoving point, the fulcrum. It's used to lift heavy objects, gain speed, or make work easier. The fulcrum is the part that doesn't move. The force is the part where effort is used. The load is the part where the work needs to be done. You can see by the length of a rubber band that it takes a lot of force to lift the load. But if we move the fulcrum closer to the load, what happens?
I know. It takes less force.
Can you spot the lever here?
That rests on a support called a fulcrum. The fulcrum is the part that doesn't move. The force is the part where effort is used.
So do you fill out with,
You feel where the blanks are, yes.
what is the support called again?
The support is called a fulcrum.
Fulcrum?
Yes, F-U-L-C-R-U-M. We'll go back over that.
What was it again?
Yes.
What's the second one? No, this one.
So the second blank under lever, the first bullet point, should say the fulcrum is the part that doesn't move. The fulcrum is the part that doesn't move. Okay? The second bullet point should say the force is the part where effort is used. The force is the part where effort is used. F-O-R-C-E. The third bullet point should say the load is the part where work needs to be done. The load is the part where work needs to be done.
The load.
Load, L-O-A-D. Okay. The lever lifts or moves loads. What does it do? It lifts or moves loads. Is everyone caught up on the lever? Yes? No, you write 2 examples.
What does it does?
It lifts or moves loads. The next simple machine is the wedge. Have any of you ever seen a wedge before?
Yes.
It looks like a door stopper.
Oh, yeah. Yes.
This is a wedge.
Should have that nice. Some still have that.
A wedge is 2 inclined planes placed back to back. They're used to cut, split, or pierce material. How many of you have seen an axe before? Someone use an axe to chop wood. At the end of that axe is a wedge. If they're hitting this, that wood just splits, right?
Yeah.
That's a wedge. It's used to cut and split material.
If it's sharp, right?
It is sharp. Some are sharp. Like that axe.
Well, some axes die out.
Yes.
I mean,
A nail can also be a wedge. The very tip looks just like this. So a tiny nail has a wedge at the end.
Now, the wedge. A wedge is 2 inclined planes placed back to back. A wedge splits or pushes materials apart. This knife can slice an apple. It's a very sharp wedge. Some wedges are really tiny, like the tip of this straight pen. It's a wedge. The head of the pen is flat. It can't go through the paper easily, but the wedge of the sharp tip can. And this wedge can separate the strongest things. Nails can pierce wood. They're wedges. So is a chisel. The blade of a plow can penetrate the hardest ground. And the wedge on an axe can split logs. With 2 wedges, or the scissors, we can cut the roof of our guardhouse.
Okay. So a wedge splits or cuts material. It splits or cuts material. When you're done with that, flip your paper over. We're on the back side. If you have anything written there already, erase it. Okay. Is everyone ready? Okay. Our next simple machine is a wheel and axle. Has anyone seen a wheel and axle? Does anyone know an example of a wheel and axle? Mark.
A weight.
A weight.
Weight. Right.
Like when you're lifting and it goes, that's a great example.
Tires on a car.
The tires on a car.
Tires on a go-kart.
On a go-kart. Orion.
A billboard that moves?
A what?
A billboard that moves?
That's a good guess. Last one.
Like little tiny plastic cars that you see the
That's a good one. A wheel is a round disc. The rod, which is the axle, is placed through its center. It helps move loads by overcoming friction and increasing speed. Here's an example. You guys see this place in the center? You also see this. Wheel and axle. Another example would be a bicycle tire. You know, it just goes round and round. That's the wheel. The center part of it is the axle. A rolling pin. It makes work easier for us. You're making pizza. Do you want to sit there and try to smush the dough together? No, that would take too long, right? So you, or you could buy one. That's true. If you're going to make it homemade, you can get a rolling pin and just roll it. This would be the wheel and the axle. Bicycle tire. Wheel and axle. Does everyone see the two parts? Yeah, he needs to get those changed.
The wheel and axle. A wheel is a round object, like a disc. It turns on an axle. An axle is a bar. The wheel turns around. The wheel by itself is not a machine, but it becomes one when you combine it with an axle. A wheel and axle are considered as one unit when they are joined to each other and work together. A wheel and axle can overcome friction. This car, sitting on an inclined plane, is going nowhere without wheels. But with wheels, look out! Not only does it overcome friction, the car, with wheel and axles, certainly goes farther. And a wheel and axle machine can increase your force, like a doorknob. It's an example of a wheel and axle machine. A little effort on the wheel puts enough force on the axle to move the bolt and open the door. But without the knob, the wheel, it's almost impossible to move the bolt and open the door. Then, there are some wheel and axle machines that don't look like wheels at all. The screwdriver is a wheel and axle machine. Can you see it? The handle is the wheel, and the shaft is the axle. It's easy to spot the wheel and axle machine here.
Would you guys have thought a screwdriver was a wheel and axle? No, I didn't either until I saw this video. On your worksheet, you should have a wheel is a round disc. An axle is placed through its center. It helps move loads by overcoming friction. 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 guys know it was an inclined plane?
Yes.
You did. Some of you did.
Yep.
Here's an inclined plane. Inclined plane. It looks like a ramp, doesn't it? Why doesn't want to stay? So, an inclined plane is a slanting surface connecting a lower level to a higher level. Basically, an inclined plane is something that helps you get from point A up here to point B down here without having to go down and left. You're just going diagonally across. So it's a slant. On here, here's point A, here's point B. It's helping the car get up here. An example of this would also be stairs, because you don't have to necessarily go down and left. You just come straight down. So it's a slanting surface connecting a lower level to a higher level. A ramp. And there's a regular inclined plane.
The first one is the inclined plane.
Is that an airplane?
No, an inclined plane. A plane is a flat surface, not the nickname for an airplane. A tabletop, a floor, even a board, these are all planes. Incline means sloped or slanted, also tilted or tipped. So, an inclined plane is any slanted surface. Inclined planes help make it easier to move things to higher places. The length of the rubber band shows that lifting straight up takes more force than pulling the weight up the inclined plane.
How does an inclined plane help us work?
You don't have to move this mower very far to get it into the truck, but it's heavy. You need a lot of force to lift it. When he used the ramp, an inclined plane, he had to roll it a farther distance, but he could do it alone. It took less force. So it's a trade-off. More distance for less force. Some examples of inclined planes are stairs, ramps for wheelchairs, roads that wind up hills, boat ramps, and playground slides. Can you see the inclined plane here?
Okay, so an inclined plane helps move objects of more distance with less force. How many of you guys would have tried to pick up that lawnmower by yourself?
I wouldn't even try.
I would hope not. I would hope you would get an inclined plane to push it or let it roll up. That would make work a lot easier for you. Yeah.
So that's why people when they're running that food in the back of something they use them.
They can just roll it up because it's easier instead of having to pick up and move it. Or a dolly. Or a dolly. That is another one. Okay, our last simple machine is a screw.
The first one is the...
How many of you guys have seen a screw? That's what all of you have a screw in your house somewhere, I guarantee you. A screw is an inclined plane wrapped around a pole and it holds things together or or lifts material. What do you guys use a screw for in your house?
Keep things together.
Raise your hand.
To hang up the doors and hinges.
To hang things up.
To keep things together.
To keep things together. Ronnie?
Oh. What holes are
Like keep things together.
To keep things together. Okay, last one. To hold things together. That's exactly right. It holds things together and lifts materials. You may have seen on the picture from it. Or how many of you have ever built something that needed a screw? So you've seen that you have to use a drill for screws. So there are 3 different kinds of screws here. And then a regular screw. So let me ask you guys a question. If I gave you a quiz asking you to list the 6 simple machines, could you do it?
No.
Okay, let's see. Someone raise their hand and tell me the 6 simple machines. Tell me one. Brianna.
Wheel.
A wheel and axle. Remember, a wheel is not a machine by itself. A pulley. Okay. A lever. Jamal. A screw. Inclined plane. And what's the last one? A wedge. So you guys know the 6 simple machines, right? Do you remember what they do?
No.
You don't think you remember what they do?
I do.
I'm not going to ask you them individually. Do you remember what they look like?
Yes.
So if I said, let's play a Jeopardy game over the 6 simple machines, would you guys get them all right?
Yes.
Maybe.
I know what they all do.
So if I told you we would play Jeopardy right now, you could work in your groups, how would you do?
Good.
Good? Well, let's see.
You're an
So what we're going to do, the last period you want to just split the teams in 2. This is A team and this is B team. Excuse me. We're not going to play this if you guys get loud.
What about the people in the middle?
Yeah, I guess you split them in half.
Is this 18?
8.
1 second, I'll answer all your questions. You have a question? So we have 3 categories. Name that simple machine. That means that I will give you a definition. I just want you to tell me which machine that is, okay? The second category. Yes. Explain that simple machine. Tell me what it does. The last category. Draw that simple machine. You come to the board and you draw which one it asks you to. Okay? You got it? So, we're going to start with the A team. Someone over here. Kelsey, pick the category. Okay, for how many points?
300.
Draw that simple machine for 300. Draw an example of a lever. Over down that floor. And remember, you can ask your team to help you.
Never.
Okay, does everyone on his team agrees with this?
No. It is. That's a screw. That's a screw.
Okay.
Not a screw. Look, your shirt too.
Someone on his team come help him. Ooh. Kelsey, pick someone to come help you.
You know what a pulley is? You don't know? I can help.
Okay, if you can't draw one, give me an example. Just list it. Say it. What's an example of a lever? A joystick.
No. I know.
Ask someone on your team.
Like a seesaw.
I said seesaw.
A seesaw. Does everyone on the team agree with that?
Yes. I said seesaw.
A seesaw.
Yeah. I used to have control. I'm like that.
Okay, someone. Oh, wrong team. From the B team.
Oh, 10 seconds.
Agree? Yes. Which category? Oh, you're waiting on me. For how many points? Okay, explain that simple machine for 200. What is a wedge used for? Oh, you don't have to draw it on the board. Can someone tell me on the B team what a wedge is used for?
A wedge is used to split wood.
To split wood? Does everyone agree with them?
Yes.
A wedge is used to split, cut, or pierce material, so that's correct.
Should be happening.
Okay? Let's see, we did a boy. For how many points?
100.
A simple machine that uses grooved wheels and rope. Wait, hold on, you guys. Put your papers. Sorry, I forgot. Someone from last period reminded me. Let's put these up.
Holding them?
Yes. Okay, does everyone have their papers away?
Yes.
I looked at it. Okay. A pulley. Does everyone agree with her? A pulley. Yes. Is that 200?
100.
Oh, yeah.
Okay, someone from the B team.
Oh, yeah.
With a girl, let's see.
No, you got to go last time. You did Brandon.
Brandon. I'm not Brandon, L-U. Draw for how many points?
200.
Oh, snap.
Draw an example of a wheel and axle.
Come on, come on, Ellie.
Yes. Okay. Which part is the wheel? Which part is the axle? Oh, you know. Does everyone on his team agree with that?
Yes.
And that was 200,
He did 400. You did 4. I mean, you did 200. I know. Why did you say?
Okay. Someone from the A team.
A boy.
Yes.
Name that machine.
Name that simple machine for how many points?
300.
How many?
300.
300? A slanting surface connecting a lower level to a higher level.
Ah, man.
You can ask your teammates.
Oh.
Kiara.
Does everyone on her team agrees with her?
Yes.
Yes. Yes. Okay, someone on the B group. We have name that simple machine for 200, explain for 100 and 300, and draw for 100.
Explain that simple machine 300.
Oh man.
What is the wheel and axle used for?
Jackson.
To roll some.
I need at least one of the two. What it does, it moves loads by doing what? I need one of the two. Ronnie.
To increase force.
Or decrease force.
Decrease force.
No,
Okay. You're close. You're going in the right direction. It doesn't increase force. It increases something else. What is it?
Speed.
Hold on, which tool is up here?
The wheel and axle.
Does anyone?
The wheel. Where's the wheel?
You guys should know this. We shouldn't have to look at these.
yes.
Okay.
To move it.
It moves it by doing what?
Creating friction.
Oops. Wait, what did you say?
I said creating friction.
Okay, I'm going to accept that.
Why?
Overcoming friction and increasing speed. No, she said friction.
Hey, all
Or
the
she
same
said
thing.
force.
No, we
I
didn't.
said force.
Force.
We got too many chances.
He said we still He said speed.
How much was that one worth? Okay, we have to finish quickly. There's something else to do. Okay, we're on a boy. No, we're on a girl. Yes. We have name for 200, explain for 100, and draw for 100. Okay? A stiff bar that rests on a support called a fulcrum. It lifts or moves loads. You can ask your team for help.
Mark. Can you read that again? I don't understand.
I need an answer.
Can you read it again? Can you read it again?
It's a stiff bar that rests on a support called a fulcrum. It lifts and moves loads.
No.
Does everyone on her team agree?
No.
Yes.
Yes. What? Don't look on it.
Yes.
Okay, that's not from being wrong. Don't say nothing. Yeah, right.
I don't want to agree. Somebody else.
Quick.
Now we only have 100 left.
Okay, what do we do on this team? Boy or girl? A girl? Yes.
It's
not a baby.
You really?
I mean, not Ellie, Brandon. I just, I'm sorry. Brandon.
No.
Brandon, I can't hear him because you're talking. Draw that simple machine. Draw an example of an inclined plane.
Oh, snap.
It's not hard. It's not hard.
Okay, let me ask you a question.
Yes.
Yeah.
No.
Yes?
Yes.
Okay. Sadly, I can't give you that point. What he drew was a lever with the fulcrum. An inclined plane looks like
I told you to draw
that. My drawing is terrible. The wedge is similar. However, one on the picture, you remember it said fourth direction up here?
Yes.
It looked like that?
Oh.
I'm scared.
Like that. Okay.
Tyler's throwing points.
The last one is this one. No, we just did draw.
Ooh.
What is the screw used for this thing?
To help.
No, to help
Keep it.
to help to keep it together.
To help
To help
keep it
connect
together.
something?
Yeah.
To keep together, does everyone agree?
Yes.
No.
No.
To hold
Hold
things
things.
together with materials.
That was right.
Oh. Yeah. Y'all can
Okay,
see
so
this.
let this team catch up. We're going to do a speed one. This is what we're going to do. Let's see. Mark and Brandon.
Oh.
Elliot.
No.
Okay, Mark and Elliot. I'm going to ask a question.
Should be her.
You're going to talk to your team. You're going to talk to your team, and the first team that knows the answer is going to throw their hand up. If you get it right, then you guys will be even with them, okay?
Okay.
Come on, Ellie.
The question is, you can talk to your team, remember that.
Do we stop when they get even?
What is the purpose of simple machines?
Oh, yeah.
That was too close. My hand went up first.
No, we didn't.
Okay, tell you.
To help us, no,
To
make the jobs easier for us.
To make jobs easier. To make work easier, that's correct.
No.
Still, you know what? Last class, because they were such great players, I told them I'd bring them candy on Wednesday. I'm not exactly sure about you guys right now.
Oh. Oh, so cute.
Okay. So if I gave you a quiz, would you pass it?
Yeah.
Maybe. No. You can't list the 6 simple machines yet?
No.
I can play another round.
Can't probably can't.
You're lucky.
Okay, underneath in your basket, you should have a benchmark book. You'll take that out and turn to page 101. We'll get the one next to you. 101. No, it's not a quiz. If you'll give me time, I'll explain to you how we're going to do this. Last class, that's working group. But that's as long as you work quietly. This you'll be working on for the rest of the class period. You're going to turn it in. So make sure you put your name and period at the top. Okay, I'm going to put one of these on each row. You're going to pass them back when I tell you to. So, as you may notice on your worksheet, there are vocabulary words for simple machines. Some of these we went over, like force and simple machine and fulcrum. Well, 2 new ones are kinetic and potential energy. Has anyone ever heard of potential energy? Kinetic. Potential energy is the stored energy, right? Kinetic energy is when it moves. Here's a great example of one. You push this down and it stays, it's storing. So therefore it's potential. When it pops up, it is kinetic because it's moving. So everyone in the first row, push yours down. to make potential energy.
It will work.
Let it go, Mark.
Whoa!
Okay, now pass it back to the person behind you so they can pop up. There you go. So potential energy is
Pop go the window.
potential energy is what?
Force.
Potential energy is stored energy. Kinetic is when it moves. Okay, pass it to the person behind you. Potential is stored energy. All right, everyone pass it to the front. You should at least have one